Hello everyone and welcome back to another video. Today I, Sean, register number URK20CS3026. I'm going to explain to you experiment number 4 of DA lab. So today we'll be implementing an algorithm that helps us to find the longest common subsequence using dynamic programming method. So our aim is to implement the algorithm to find the longest common subsequence using dynamic programming technique. Over here, this is the algorithm. In this, we taken two strings, that is x and y, and here we have taken m and n as the lengths of the strings x and y respectively. Then we have initialized table, dynamic programming table dpt is equal to none of n plus 1 for range m plus 1. That is like it will print none arrays of n plus 1 size for a range of m plus 2d array of n plus 1 into m plus 1, and then implement a nested for loop for I in the range of m plus 1, in that for j in the range of n plus 1. If I is equal to 0 or j is equal to 0, that is when we are taking a dynamic programming table, we start with 0, and so in that case we are not selecting any character from that string. So in that case it cannot be equal to the other strings, whichever amount of characters you select. So in that case it will obviously be 0. So we have initialized dpt of I comma j to be 0, and then else if the first string x of I minus 1 element, that is the previous element of the string, is equal to the previous element of the jth string, in that case our present string will be having dpt of I minus 1 and j minus 1, that is a diagonal element we'll be taking, and we'll be value and incrementing it by 1. And else if we have the dpt of I minus 1 comma j is greater than dpt of I comma j minus 1, in that case whichever is higher, this is higher, in that case we'll be taking the value dpt of I minus 1 comma j, that is, and we'll be assigning the value to the lower cell. And else if this one is higher, that is dpt of I comma j minus 1, that is the upper cell, in that case we'll be taking this and assigning it to the current row. And then this is using backtracing, we are going to be finding out the sequence of the common characters, longest common subsequence. So we assign s for the sequence, and then we initialize I is equal to n and j is equal to m, and as long as I is greater than 0 and j equal to greater than 0, start with the highest values, that is the bottommost of our dynamic programming table, and from there on, if that is equal, that is diagonal element, like the left element and the top element of the thing is equal, in that case we know that the diagonal has been copied with 1, and in that case we will be directly knowing that there has been a common element in that case. And here s we will be adding x of I minus 1, or you can add of the same as y of j minus 1, you can do the same, and then we will be decrementing I by 1 and j by 1, we will be moving up diagonally. And then else if that is not the case, that it is not the same, in that case we don't have a common element. And if dpt of I minus 1 comma j is greater than dpt of I and j minus 1, in that case we will be moving to the left by 1, because on the left is greater, and that is what got copied. If that is not the case and the element on the upper part of the cell is higher, in that case we will be decrementing j by 1 and we will be moving up by 1. And then finally, once this while loop is done, that is either I is lesser than 0 or j is lesser than 0 or it's equal to 0, in that case we will be stopping this while loop, and by then we will be having our longest common subsequence. And then we'll be returning the last element of the dynamic programming table, that will be having the maximum number of common elements, the longest common subsequence, how many elements it has, and we'll be also returning the subsequence, taking the first input and the second input from the user. And here n comma s are the two outputs that we'll be getting. I assign them to n and s, that is of the subsequence LCS is n, and then the longest common subsequences is s from the start to end, but from the reverse, that is minus 1. From the end we will be starting and minus 1 minus 1 till 0. We will be doing this because when we are doing a backtracing, that time the last common element will be stored first, the second last common element will be stored second, and so on, because of which we have to get it in the proper way, we'll be having to reverse it, and we'll be printing it in reverse using this. So let's run it once more. So let's enter the first string as road. traffic. And second one, let's enter it as road truck. So as you can see, the longest common subsequence has 7. There's also a space included in the middle of both of these that is counted in the longest common subsequence. That's why a total of the length of the longest common subsequence is 7, and it is ROD space TRC. So thank you guys for watching this video. If you enjoyed the video, do give it a like and do subscribe to my channel for more such interesting content, and hope to see you guys in the next video.